2004 Canadian Open Mathematics Challenge, Part B. The points A, -8, 6, and B, -6, -8 lie on the circle x squared plus y squared is 100. Determine the equation of the line through AB. Okay, let's draw a very simple diagram, and let's see what this looks like. This diagram should serve the purpose. So for part A, they want you to find the equation of AB. So this was A right here, and this was B. Okay, not a problem. We have 2 points. Equation of any line is y is equal to mx plus b. M is the slope, which is the rise over the run. So it would be -8 minus 6 over -6 minus 8, so plus 8. That looks like -14 over 2, which is -7. So this is y equals -7x plus b. Substitute either of these points in to figure out the value for b. So I will do that. Y is 6 when x is equal to -8. So that looks like b is 6 minus 56, so b is -50. Therefore, the equation of the line through AB, that red line, is -7x minus 50. All right, that takes care of part 1, or part A, I should say. Part B, determine the equation of the perpendicular bisector of AB. Okay, perpendicular bisector. Alrighty, so let's draw what perhaps is the perpendicular bisector. Perpendicular. Okay. So something like that, right? So it's perpendicular. So that means this is a right angle. And bisector meaning it cuts it in half. So those two segments would be equal. Okay. Let's see if I can do this now. So because it's perpendicular, the slope would be the negative reciprocal of that. The negative reciprocal of -7 is 1 over 7. And then the equation of the line would therefore be y is equal to 1 over 7x plus b. To figure out b, I need a point on the line. The point on the line is right there, because that is the point that I can figure out, because it's the midpoint of AB. And midpoint, you just use the midpoint formula. So that point I'll just call M for midpoint. M using the midpoint formula on those two coordinates would be -8 plus 6. So you're just adding -6 divided by 2. And then 6 minus 8 divided by 2. And then that is -7 minus 1. So M has these coordinates. So substitute that into here. When y is -1, x is -7. And therefore, what's that? B is 0. Okay. So that means the equation is y is equal to x over 7 of this green line part. That takes care of part B. Moving along to part C, the perpendicular bisector of AB cuts the circle at 2 points P in the first quadrant and Q in the third quadrant. Determine the coordinates of PQ. All right. So this diagram helps because that means that this is P and this is Q. Okay, how do I do that? Of course, I've got to take that into consideration, that the equation of the circle is x squared plus y squared is 100, and the equation of the line is this, y is equal to x over 7. So I just have to substitute that into this and solve. Shouldn't be a problem. Okay, so here we go. So y is equal to x over 7, so let's plug that in. We got x squared plus y squared, but y is x over 7 squared is equal to 100. So this is x squared plus x squared over 49 is equal to 100. Get a common denominator, top and bottom by 49. So this is 50. X squared is equal to 100 times 49 when you cross multiply. Continuing, we get 50x squared is equal to 4,900. Divide through by 50 and you get x squared is equal to 98. Therefore, x is equal to plus or minus the square root of 98, which is, what is the square root of 98 in terms of a mixed fraction or mixed radical? What is that, 7? Yeah, 7 root 2. Okay, so that means that one of these is positive. Obviously, p is the positive one. P is 7 root 2. And then q is obviously the negative 7 root 2. And then we just have to figure out the y coordinates. And you do that by plugging in back into there or there. I think this line equation is easier, so I'll do that. When x is 7 over root 2, y would be equal to root 2. So this is root 2. And then when x is equal to minus 7 root 2, y is equal to minus root 2. So minus root 2 we squeeze into there. And there you go. Those are the coordinates. P is 7 root 2, and q is minus 7 root 2, minus root 2. What is the length of PQ? All right, the length of PQ should be pretty easy to figure out. We just have to use these 2 points right here with the distance formula. Okay, so the distance formula is d is equal to 7 root 2 minus 7 root 2, so we're going to add that, squared, and then root 2 minus root 2, which is root 2 plus root 2. All under the square root sign. So this is what, 14 root 2 squared plus 2 root 2 squared. And that looks like 392, and that is 8. So it's root 400, and root 400 is 20. The answer to part D of number 1. Determine the 2 values of x such that x squared minus 4x minus 12 is 0. Okay. I think that should factor. X squared minus 4x minus 12 is 0. So if I factor, let's see, what do I get? X, 6, and 2. And then negative positive, I believe. So that means x is equal to 6 or negative 2. And I think that's it. So that takes care of part A. That's pretty easy. Part B. Determine the one value of x such that x minus the root of 4x plus 12 is equal to 0. X minus 4x plus 12 is equal to 0. Okay, put that radical on the other side, 4x plus 12. Take the square of both sides, so x squared is equal to 4x plus 12. And then what do I do now? Just put it all on one side, I guess. And then I think I end up getting the exact same thing as before. So I factor just as before, and I get the exact same result. Okay, so x is either 6 or minus 2. But here's the thing, I've got to go back and verify if that is actually going to be true. So for x equals 6, let's see, what do I get? I'm plugging it back into here. I get, let's see here, 6 minus 4 times 6 minus 12 under the square root sign. And that is 6 minus, well, 24 minus 12 is 12. 24 plus 12, it should be plus, sorry about that. 24 plus 12 is 36 under the square root sign. And that's 6 minus 6, so that is indeed 0. So for x equals 6, it works. Now let's try x equals negative 2. Let's see what happens. So if x is equal to negative 2, what is the scenario? So we have x is minus 2 this time. We're testing this. So minus 2 minus 4 times minus 2 plus 12. And then that would be minus 2 minus negative 8 plus 12 is 4. So that's going to be minus 2, which is negative 4. Interesting. So that is not equal to 0, right? Because it has to equal to 0. So that means the only valid solution, the one value of x that they want you to figure out, is x equals 6. So that's it. Determined all real values of c such that x squared minus 4x minus c minus the square root of 8x squared minus 32x minus 8c is equal to 0 has precisely 2 distinct real solutions for x. Okay. So let's give ourselves some space here. Okay. So off we go. All right, so we've got this equation. It is x squared minus 4x minus c is equal to the square root of 8x squared minus 32x minus 8c, right? When you put that on when you put the radical on the other side. Now square both sides, and when you square both sides, you'll get x squared minus 4x minus c all squared, of course, and then the radical on this side disappears. So you just get 8x squared minus 32x minus 8c. Okay, well, we got to do the painful expansion. Oh boy. But, you know, instead of expanding, I think it'll make our life a lot easier, because I look at this and I quickly see that this is very similar to that. So if I let x squared minus 4x minus c equal to something, let's call it m, then I think I can get this in terms of m also, because that is really, if I factor out an 8, it's x squared minus 4x minus c. Yeah, exactly what I thought. So if I let this equal m, this will become m squared, and then it would basically be is equal to 8m. Yeah, that's a better approach, I think. Okay, so let's do it that way. So now, if I try to solve it, it'll be m squared minus 8m is equal to 0. Factor out the m, and that means we have m minus 8. So that means either m is 0 or m is 8. Okay, I think that's a much better way of doing this. So now let's work with both of these. So I guess first we start with m equals 8, and then we will do m equals 0. Okay, so when m equals 8, we have x squared minus 4x minus c is equal to 8. Correct? So that means we have x squared minus 4x minus c minus 8 is equal to 0. Now we have to use a quadratic to solve this now. Okay, hopefully this is not going to be too painful. So x is minus b plus or minus the square root of b squared minus 4ac all over 2a. And therefore this is 4 plus or minus 16, let's see here, plus 4c plus 32 all over 2. So this is x is equal to 4 plus or minus 48 plus 4c all over 2. And then when you kick out that 4, it becomes 4 plus or minus 4, or actually 2, because you're going to have to take the square root before kicking it out of the radical. And then that's going to be 12 plus c all over 2. And then finally, it'll just be 2 plus or minus the square root of 12 plus c. Okay, that's pretty cool. So therefore, now we have to say, well, what's the conditions on c? Well, the radical obviously has to have inside it something that will be greater than or equal to 0, non-negative. So that means 12 plus c has to be greater than or equal to 0. Otherwise, it will be imaginary numbers. And I think they wanted real solutions, right? If you look back. Real, yeah, they wanted real. Okay, so that means 12 plus c has to be greater than 0. So that means c has to be greater than or equal to negative 12. Okay, so that means when c is equal to minus 12, this whole thing will vanish. So x will be just equal to 2. So you'll have one solution. And when c is greater than minus 12, then you will actually have a number there. It might be a square root of something, but it'll still be a real number, and then it'll give you 2 plus or minus that. So there'll be two solutions. So there'll be two solutions. Okay, all right, great. So we took care of when m was equal to 8. Now we have to do the other one. If you recall, it was m equals 0. So same kind of story. So this time x squared minus 4x minus c is equal to 0. Using the quadratic formula, 4 plus or minus the square root of minus 4 squared minus 4ac all over 2a. X is equal to 4 plus or minus 16 plus 4c all over 2. X is 4 plus or minus, take out the 4, that would be a 2. So that would be 4 plus c all over 2. And then this is going to be just x is equal to 2 plus or minus 4 plus c. So very similarly, the 4 plus c has to be non-negative, so it's got to be greater than or equal to 0. So therefore c has to be greater than or equal to negative 4. So when c is equal to negative 4, you will have one solution. And when c is greater than negative 4, you will have two solutions. But we have to combine these, right? Because we've got two scenarios, so we have to combine them. So to combine them, let's make a little table. It doesn't have to be a work of art. Let's see here. Okay. So we've got how many different scenarios here? We got, I think, at least 4, maybe 5 actually. All right. So we have the first one where x squared minus 4x minus c was 0, and then the other one where x squared minus 4x minus c was equal to 8, positive 8. And then right here and right here, we concluded that when c was less than, let's see here, when c is greater than minus 4, and then we had c equal to minus 4. I'm just figuring out the ranges here. And then here we had c equal to minus 12. And then the range before it would be less than minus 12. And then this range would be between minus 12 and minus 4. Okay, perfect. Okay, so let's talk about this. So when we have this equation, when c is equal to minus 4, we have one solution. So one solution. And when c is greater than minus 4, greater than minus 4, we have two solutions. Okay, so two solutions. And then when it's less than minus 4, there would be no solutions that are real. So 0, 0, 0. In that range, you don't get any real solutions. Now let's look at this guy. When c is equal to minus 12, we get one solution. When c is greater than minus 12, we get two solutions. So greater than minus 12 would be these categories, correct? Greater than minus 12. And then this would be 0 because it's less than. Okay, now we got to look at the total. The total has to be 2. 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4. We want this guy right here. And that is for the interval minus 12 to minus 4. A little bit, not very tricky, but you got to take into consideration the total aspect of this question, not just look at individual equations. A map shows all Barrels Llama Burgers restaurant locations in North America. On this map, a line segment is drawn from each restaurant to the restaurant that is closest to it. Every restaurant has a unique closest neighbor. Note that if A and B are two of the restaurants, then A may be the closest to B, but without B being the closest to A. Prove that no three line segments on the map can form a triangle. Okay. Let's see here. Let's say they do. So let's say we've got three restaurants and we'll label them A, B, and C. And then when you draw them all out and connect them, they form a triangle. We have to show that this is possible. If it's not, then we've proven that there's no such scenario. Okay, so let's talk about this carefully here. A and B are connected, correct? So since they're connected, we know this line, every restaurant has a unique closest neighbor. Okay, so I don't know what the exact scenario is, so I will assume that A is the closest restaurant to B. Now, if that is the case, then since only one restaurant can be the closest to the other, we can conclude, therefore, that C is not the closest restaurant to B. Correct? Because every restaurant has a unique closest neighbor. Every restaurant has only one restaurant that is closest to it. So we first were looking at B and kind of trying to figure out how this would be. So A is the closest restaurant to B. Therefore, C is not the closest restaurant to B. That's my assumption. If that's true, then that means that the distance from A to B is less than the distance from B to C. Okay? So that is the first established fact. Okay, moving right along. Same way, let's talk about C and B now. So we have C and B are connected on that graph. Same thing. Since C is not the closest restaurant to B, as I wrote here, what that means is that B is the closest restaurant to C. Because every restaurant has a unique closest neighbor. And if they're connected, then one has to be the closest restaurant to the other. So we got to figure out which one it is. And so we made this conclusion here. Okay, if B is the closest restaurant to C, that means A is not the closest restaurant to C. And just as before, we can therefore conclude that the distance from B to C is less than the distance from A to C. And that will be my equation 2. And in the exact same way, I'll let you do the third scenario. I think by now you've become an expert. If you look at, by the same logic, C and A, since B is the closest restaurant to C, established here, that means that A is not the closest restaurant to C. Now, since A and C are connected, that means that one of them has to be the closest restaurant to the other. If A is not the closest restaurant to C, that must mean that C is the closest restaurant to A. And if that is the case, then that means that B is not the closest restaurant to A. So now that means that we can create another inequality that AC is less than AB. And that will be my equation 3. Okay, now combining equations 1, 2, and 3, let's see what we get. We've put them all together. Get BC is less than AC. That's this guy. AC is less than AB over there. And then AB is less than BC. Well, look at that. That doesn't make any sense, right? That's not possible. Not possible. So what that basically proves is that it is impossible to form a triangle like this with 3 line segments based on the criteria given in the question. So just write that out and you'll be done with part of this question, which is part A. Part B, prove that no restaurant can be connected to more than 5 other restaurants. All right. So I'll put that down here. I'm going to need some space. So here we go. Okay, so how we're going to approach this is basically by first making a scenario that it is connected to more than 5 restaurants, and then trying to disprove that. So our original assumption is that we've got this restaurant A, and that's connected to 6 restaurants, more than 5, right? So 1, 2, 3, 4, 5, 6. And we'll label them B, C, D, E, F, G, like that. Okay, so our original assumption is that one restaurant can be connected to 6. One restaurant can be connected to 6 restaurants. And if we can prove that this is not possible, then we will have shown that part B is indeed proven. Okay. So first, let's just concentrate on these 3 guys, A, B, and C. And let's talk about those restaurants A, B, and C. Okay, so here we go again, right? A is the closest restaurant of B. So we are assuming that. Let's just say that A is the closest restaurant to B. That means that the distance from A to B will be less than the distance from B to C if we were to connect B to C, like that. Right? Because A is the closest restaurant of B. So C is not the closest restaurant to B. You see what I mean? That's why we get this. Very similar to what we did before. Now, if that's sort of what we are establishing, then we have 2 possible kind of directions to go at that point. The first direction, which I guess I'll call case 1, and then the second direction, case 2. The first case is that C is the closest neighbor of A. And if that is the case, then the distance from A to C is less than the distance from A to B, right? Because if C is the closest neighbor of A, B is not the closest neighbor of A. So the distance from A to C would be less than the distance from A to B, correct? So this is equation 1. We now created an equation 2. Okay, so if we combine A and B, that means that AC is less than AB is less than BC. So it's nice. It kind of, there's no contradiction there. Okay, case 2. Case 2 is that if this holds true, then we will say that A is the closest neighbor of C, because A and C are connected. So if A is the closest neighbor of C, B is not the closest neighbor of C. So that means that AC is less than BC. That's equation number 3. Combining equation 1 with equation 3, we get that AB is less than BC, and AC is less than BC. So BC is greater than both of them. Now notice in both of those cases, right, BC is the largest side in both of them. Whether you're case 1, it ends up as the biggest, or in case 2, it ends up as the biggest. So BC is the largest. BC is the largest side of the triangle ABC in both scenarios. And therefore, the angle that's opposite will be the largest. And in this case, that angle is right here. Angle opposite of BC is right here. So I'll just call that theta. So therefore, the angle opposite of side BC is the largest angle of that triangle. Triangle ABC. Okay. All right. So we are making some good progress. Okay, that was what I needed to establish right here. Now that that is established, we can move forward with the final part of the question. Now, if this theta is the largest angle of that triangle, remember the sum of the angles of a triangle, as you all know, is 180 degrees. So that means that this angle, theta BAC, which I call theta, must be greater than 60 degrees. If it's the largest, there's no way it could be 60 degrees or less. It has to be greater than 60 degrees because the other two have to add up to 180. So that's an important, very, very important, so important that I'm going to put a star that's going to help us. And now, in a very similar way with the same logic, you can go through all the other triangles. This triangle, which is ACD, that triangle, AED, that triangle, and that triangle. And you can do, when you do that, you'll be able to prove the same thing, that those internal angles, this one, this one, this one, this one, and this one, are all greater than 60 degrees, just like I did there. So that means we can conclude that angles, so all of those internal angles, CAD, DAE, and so on, right? EAF, FAG, and GAB are all greater than 60 degrees. Okay, great. Now we come to the final part of the question, which is when you add them all up, the sum, what do we got here? We got 1, 2, 3, 4, 5, 6. The sum of these 6 angles, therefore, would be greater than 360 degrees. So each is greater than 60. But that is not possible because the sum of all of those angles should be equal exactly to 360. Correct? I'll write it up here. Sum must be equal to 360. We have shown that it's greater than 360, and that is a contradiction. So because it's a contradiction, we go back and conclude that our original assumption is incorrect. And therefore, we have proven that it is not possible for one restaurant to be connected to 6 others. And that is pretty much what they wanted in Part B, that prove that no restaurant can be connected to more than 5 other restaurants. In a Sumac sequence T1, T2, T3 till Tm, each term is an integer greater than or equal to 0. Also, each term starting with the third is the difference of the preceding 2 terms. That is, Tn plus 2 is equal to Tn minus Tn plus 1 for n greater than or equal to 1. The sequence terminates at Tm if Tm minus 1 minus Tm is less than 0. For example, 120, 71, 49, 22, 27 is the Sumac sequence of length 5. Find the positive integer b so that the Sumac sequence 150, comma b, comma dot, dot, dot has the maximum possible number of terms. Okay. We'll start off, of course, with what they gave us, which isn't much, 150 then B. And then let's list some of the next few terms. So we've got, we'll do 10. So we got T1, T2, T3, T4, T5, T6, T7, T8, T9, T10. Okay, and let's see. So we get these terms by using this formula right here, that it's really just the difference of the preceding two terms. So T3 would be 150 minus B, right? 150 minus B. Just using that formula up here. And then just keep going like this. So T4 would be 2B minus 150. Yeah. And then T5 would be 300 minus 3B. T6 is 5B minus 450. T7 is 750 minus 8B. T8 is 13B minus 1200. T9 is 1950 minus 21B. And T10 is 34B minus 3150. Okay, let's see. So this is a pretty good start. Now, for this to be a Sumac sequence, that means that we keep going until one of these becomes negative, as you can see here. Once a term becomes negative, then that's it. The sequence ends. So let's see what happens here. So for the first one, that is already positive, so that's good. B, well, for B to be positive, B has to be greater than or equal to 0. Non-negative, basically. The sequence terminates if it's less than 0, if a term is less than 0. 150 minus B has to be non-negative, so that means that 150 minus B has to be greater than or equal to 0. And that means that B has to be greater than or less than, or equal to 150. You got to be careful here. All right, and then just keep going like this. For this guy, 2B minus 150 has to be greater than 0, and therefore B looks like it's got to be greater than or equal to 75. Similarly, 300 minus 3B has to be greater than or equal to 0, and therefore B is going to be less than or equal to 100. So you just keep going like that, and then for this guy, I'll just write out, it's going to be B's got to be greater than or equal to 90. For this, B has to be, let's see here, this is T7, right? So B's got to be less than or equal to 750 over 8, which is what, 93 and 6 over 8. Yeah. For T8, we've got B has got to be greater than or equal to 1200 over 13. And what's that? In terms of mixed fractions, it's 92 and 4 over 13. And then I'll just do one more. The T9 gives me that B is less than or equal to 1950 over 21. And therefore that, in terms of mixed fractions, is 92 and 18 over 21. Okay, so let's see here. Let's talk about this. So if B is an integer, then that means that if we look at these, if we choose, especially if you look at these guys over here, they're getting close to that number, right around number 93. So if we choose B equal to 93, let's see how many will turn out to be positive here. If B is 93, well, 150 is just 150. That will be positive. Does 93 fit into these inequalities? Yes, 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 because 93 is greater than 90. Is it less than 93 and 6/4? Yes, it is. Is it greater than 92? Yes. And is it less than? No. No. So it looks like I'm okay until T8. And then once you get to T9, it becomes negative, and therefore the Sumac sequence ends. So that's pretty much as far as I can go. So it looks like B equal to 93. Sorry, that should have been a 93. Sorry about that. When B equals 93, the first 8 terms would be greater than or equal to 0. And then the 9th term would be negative. So the sequence would be maximized in terms of its length with B equals 93. And just as an FYI, the numbers would be from T1 onward. They would be, let me just write them in. Well, this is 150. This would be 93. This would be 57. 36. T5 would be 21. T6 would be 15. T7 would be 6. T8 would be 9. And then T9 would be negative 3. And that's why the sequence would end, because it terminates when a term is less than 0. So choose B equals 93 so that the Sumac sequence has the maximum possible number of terms.